So let's discuss isotopy. So isotopes are atoms of the same elements with the same atomic number but different atomic masses. Or isotopes are atoms of the same elements with the same number of protons but different number of neutrons. E.g., chlorine has two naturally occurring isotopes. So we have chlorine 35 and chlorine 37. So this is mass number or atomic masses. So that is, if I have element X, any number you write here usually represents atomic mass, and any number you write here usually represents atomic number. So any number you write here is atomic number, any number you write here is atomic mass. So if you look at this chlorine now, so we have chlorine 35. That means the atomic mass of this chlorine is 35. Also we have chlorine 37. So the atomic number of chlorine, if you check your periodic table, chlorine is in position 17. So that means the atomic number of chlorine is 17. Also, this will also be 17. So now look at the definition again. Isotopes are atoms of the same element with the same atomic number but different atomic masses. So see the atomic masses here. I have atomic mass 35 and atomic mass 37. So that is for this definition. So meaning is different. So isotopes are atoms of the same element because we have chlorine, we also have chlorine with the same atomic number. So they both have 17, 17. But different atomic masses. They both have 35 here and this one have 37. So that is the definition. So any element that exhibits it will have an isotope. And that is what we mean by isotope. Ability of element to have different mass number but the same atomic number. And note that atomic number is also the same thing as number of proton. So now let's analyze the second definition. The second definition of isotopes here, we say or isotopes are atoms of the same element with the same number of protons. Take note, number of proton is equals to atomic number. Take note of that. So now the second definition say that isotopes are atoms of the same element with the same number of protons but different number of neutrons. Let's use chlorine again as example. So chlorine again has atomic number 17. So and this atomic number, take note, is also the same thing as proton number. So that means that the number of proton is also 17. So the proton number is 17 and the atomic mass is 35. And we have chlorine 37. Also, the number of proton is also 17. So now isotopes are atoms of the same element with the same number of protons, that is 17, 17, but different number of neutrons. How can we get the number of neutrons? So take note that mass number or atomic mass, so mass number or atomic mass is equal to number of proton plus number of neutron. Number of neutron. Take note. So mass number or atomic mass is equal to number of proton plus number of neutron. So because if you have, you remember, if you are drawing your shell, the shell will have nucleus first. Inside the nucleus, you have neutron and proton. So and then you have electron that surround it. So the sum of the neutron and proton is called your mass number or atomic mass. So this is general formula now that relates mass number or atomic mass is equals to number of proton plus number of neutron. So if we write this in short, so I can say mass number m or atomic mass is equals to number of proton, that is p, plus number of neutron, n. So we can now give this as general relation. So atomic mass or mass number is the same thing as proton plus neutron. So now let's take this chlorine as example now. Remember they both have 1717, that is the number of proton. Now let's take for 35. The mass number is 35. So for chlorine 35, atomic number 17 or number of proton. So that means the mass number, use this relation now. So this will be 35 is equals to number of proton is 17 plus number of neutron. We represent it as n. So now you can collect like terms. So this will be number of neutron is 35 minus 17. So number of neutron is 18. That means the number of neutron present in this chlorine 35 is 18. Also for chlorine 37 with no atomic number or number of proton 17. So we have 37 equals 17 plus number of neutron. So number of neutron is equals to 37 minus 17. Number of neutron is 37 minus 17, so we have 20. So like that. So you can see now that this chlorine, they both have the same number of proton, that is 1717, but they have this different number of neutron, that is 18 and 20, as in like that. So that is what the second definition is talking about. So now the first definition is talking about isotopes are atoms of the same element with the same atomic number, that is 17 17, but different atomic masses, 35 37. But the second definition is talking about isotopes are atoms of the same elements with the same number of proton, that is 17 17, but different number of neutrons. So we have 18 and 20 in this case. So that is the two definitions. So we can now go further to the abundancing and the formula. Then we talk about how to use it to calculate the relative abundance, or to find the percent, or to find the number of isotopes, etc. So I'll do that in next video. So this just explain the two definitions.